Okay, hi guys, welcome to our first weekly briefing session. This will give everyone a chance to catch up with what's been going on throughout the week and everyone else give us an idea of what's been happening as well. So firstly, we're going to have a chat about Mark Smith commenting on one of our Novinet blog posts suggesting a secure Skype alternative, and David's going to tell us a bit more about that.
Right. Secure Skype, well, there's a few different ways to look at this. It's a pity Prakash wasn't here actually, because he's talking about doing secure Skype just with routing. I don't know if he was talking to you about it, but when we look at the whole system, we look at the whole kind of drop from a Dropbox kind of angle, or that sort of way, or a way of sharing disk space and whatnot. And that's how recently we're looking at changing the MaidSafe Life Stuff library to MaidSafe Client, because that's the way folks should go into the system. Once you've got a client and you're logged in, then you get all the advantages that we've coded for, you know, the security and anonymity and privacy and whatnot. From a communication perspective, it's dead simple to see how we could put in to the system a messenger system. We've already got that. We've had Messenger up and running. That's not a problem. So that's sending text from one person to another is easy through the whole Vault network. Skype and products like that are slightly different, and there's sort of two ways I think that we should be thinking about Skype. One is you make this connection. So if I'm going to speak to you in some kind of voice over IP thing, whether it's video or voice, I have to find you on the network and then connect to you, and then the data goes between the both of us. You don't necessarily need to be storing information at this point, so there's no need for you to have like a vault or something like that, because you don't need to store stuff. You're just looking at it and listening to it. And if you wanted to store it, you could store on your local hard drive or whatever. So from the Skype perspective, I think Prakash is right. You don't need to go down the whole vault route. You can actually use the routing network and RUDP to find the person. Then we have to have a directory somehow, and that's where Skype, for instance, used this global index to get that directory. We wouldn't have that kind of thing, so we would have to have a way in the system. If someone built this like Mark, and I think, was that the one that was GPL group? We were looking for GPL stuff.
It was, yeah.
Aye. So if there's a team of people building a Skype thing, we can actually do it directly on top of routing and just put a GUI on top of routing, and that would allow their nodes to find other nodes. Now they'd have to put a couple of things in there, like a node identifier, and keep that node identifier, which would be done on a disk file or something like that. It could equally be retrieved from the network. Once they find the node, so routing would help find the node really, really quickly, and it's fully encrypted, which we'll probably talk about when we talk about the meshnet guys, why that encryption is important. On finding the person, then we would initiate just an encrypted SIP connection, and that would come through our UDP, but as UDP packets. So they would be encrypted UDP packets. So what that really means is, right, so we'd have a network of nodes. And on top of this network, routing would be running. So this node here would be A, B, C, something. And this D, E, F, blah, blah, blah. An unpronounceable or hard to remember 512-bit address. So if you look at the software stack, so if you, at the application level here, there would have to be a way to tie D, E, F, ... to John, or whoever that is, and ABC to Alice or something. As long as that's done at the application level, we can handle all the security and all the finding of these nodes, and that on top of it would allow secure communications. So those secure communications will be real time. So not like Messenger or email or whatever, these are real-time communications. So it's something, you're not really trying to store anything here. This is create a connection, send it, you're looking at it, you consume the information and then it's gone. A bit like Skype just now. So we can do that right on top of routing. So that could happen today. Given the Vault network is nearing completion, it makes this even more exciting because you can have the exact same underlying technology, the same network, but this connection of these is automatic once Vault's in place. So once you get your public name in the Vault network, this mapping becomes automatic. So then you're getting real-time communications, but you're also getting tertiary communications like email or messenger or whatever that would store on your drive. So they would store on your virtual drive.
Why would you want to do it without routing then? If Vaults is so advantageous, why would we consider doing it without, sorry, just doing it with routing, sorry?
Just with routing, this is really if somebody's looking purely to do some kind of real-time consumption only system that didn't store any recording or data.
It's like a Snapchat equivalent.
Yeah, it would almost be something like, almost like Skype, you make the phone call, you say what you're saying, put the phone down, it's gone. If you wanted to record this stream here, what you could do is record it to your normal hard disk, but then from a security perspective, for us, the way that our network works, we would see recording to a hard disk as a huge barrier to any privacy. So it could be snooped on and whatnot. So we would provide, if we had two people, if you had someone here talking to someone over here, we would provide a system where they've got incredible security between these 2 points. But if they then come off that system and store to a local hard drive, that's insecure. So we don't support anything in that environment at the moment. When vaults come into play, that hard drive becomes the VFS, which is then extremely secure, and we do support that natively. So you can have real-time consumption-based comms at the moment. We just don't supply a mechanism to store. It doesn't mean somebody couldn't actually code in and say, well, we're going to store locally, we're going to store it in an encrypted file or whatever. It's more advantageous to have vaults, I think, for the bigger picture.
Cool. Any more questions?
Would we, just on that, would we try and offer any support for an alternative for the public key to public name mapping? Because we always provide that through vaults, but...
I've never really thought about that part, I don't know. I suppose we could investigate it. I don't know the easiest way to do it
There's
though.
not really anything better than vaults, I don't think.
No.
But it would just be providing a really pared down version of vaults, I guess, would be all these stores public keys.
You could look at some things like somehow creating something where we could use a bit of the code that you did, the reversible hash function. So you could actually make the hash as the hash of John as the actual ID, but you could reverse that hash just to get back to that ID.
Mm-hmm.
But again, I think what that's doing is probably leaking
Yeah.
quite a lot of security for us.
Yeah.
Because throughout the network, each bit of traffic that goes through could be decoded with the next hop, so they'll figure out the destination and source and stuff. So
It's a message, wasn't it, to use routing on its own? It really
Aye.
needs to be, there needs to be an answer to that.
yeah, I think that's one of the hardest parts for these guys, and they might need to have something like a global index
Yeah.
or a server-based solution that's got that mapping in place. So that's going to definitely weaken it. So they get the security that they can't get with Skype and whatnot in terms of nobody can snoop on this conversation.
Yeah.
But the global index thing, which Vaults provides a significantly better global index, would be gone.
Okay.
What do you think of that, Mahmood, for using routing for Skype.
As you mentioned, I think the most important part, it needs something on the top to just do this mapping.
Yeah,
So if this mapping exists,
yeah,
that's the only thing which is required.
yeah, I think that's the missing links. Prakash may have something to say about it next week, if he's here. So,
Yeah, that's. Next up, there's been big discussions in Reddit about this. David's going to fill in what's been posted.
Reddit, yeah. Yeah, Reddit's quite interesting. I don't know, did you all see that discussion? The interesting thing about that discussion is primarily that group are looking at mesh networking, and mesh networking's, it's not new, it's been about for an awful long time. In fact, one laptop per child and whatnot, their computers are built in to do mesh networking, and what that does is the simple way to is if you've got a connection to the internet here, and this person connects to the internet, with a mesh network, and there's quite a few standards for this now. These guys all connect to each other. Now, different mesh networks do it differently. You might find that somebody here with another internet connection or whatever. These guys here will hunt through the route, so they might take that route, or they might take this route, or they might, in some mesh networking systems, they'll aggregate both of these routes. So these guys will, in here, end up putting their own metrics in place, and they'll give each route to a resource, which is bandwidth here, a number. And using these metrics, we'll figure out the best way to get to the internet or get to something else. Where those guys are coming from, those meshing guys, is they're basically saying, what if we don't have the internet here? What if this network just goes and becomes the internet? Is the ultimate goal, really. So that internet connection here is your usual ISP, so BT or Small World or one of these kind of things. So that group in Reddit in particular is looking for alternatives to an ISP model. So how to connect people together without ISPs, not necessarily on the internet, but that could be part of it. I think the only way that this mesh networking would work would be that's okay in a built up area. These things tend not to be too far. Some of them are a couple of miles now. But you'd have a built up area here and another built up area here, and there has to be a sort of backhaul connection. And that's where the internet is really good. Unless we start doing things like Project Loon, with balloons up in the sky or some sort of satellite low Earth orbit stuff to connect these groups of mesh networks together. But anyway, that's another story. These guys are looking to replace this ISP situation here with mesh networking. And a lot of that has got to do with security as well. Security is quite a big issue, because you don't want to just connect to some mesh networking guy who just reads all your stuff, because that's going to be really bad. And one of the things that we never discussed on the Reddit thing, which is quite interesting, is if the resource is over here, so say it is the internet, that's the resource, and some guy here appears and he's some sort of crooked fellow, or someone who just wants to snoop, so it could be NSA or something like that. So he just needs to present a great big resource here and have a node that's part of the mesh network. And these people will start being attracted to that resource very quickly. And through the internet to some other mesh crowd over here, whoever it is they're connecting to. For whatever reason they're connecting to them, which is none of our business, we don't get involved in that. It's this guy's business though, because he's going to steal their money or steal their privacy or something. If he can attract the mesh network to connect to him and then forward over this way, and that data connection is not secure, so it's not encrypted, then there's a big issue. How that's done just now is a thing called onion routing. And onion routing is based in somehow anonymising parts of the network, and everybody comes out of this node, say in a Tor type network. This would be a Tor, I can't remember what they call the boundary nodes, but it's a Tor boundary node anyway. And what would happen in a Tor type network is these guys would all prefer this Tor guy, and they encrypt between these 2 points, and this goes out pretty much decrypted to whatever source it's going to and goes back and then gets further encrypted. So this guy might get the information, but he wouldn't know who supplied it. He wouldn't know if that information came from him or him or him or him. These Tor nodes are getting shut down just now. Germany, there's been a few of them shut down. There's a couple of issues with them, but they're based on the kind of old model of networking, the kind of pre-MaidSafe stuff, in that the resource that people are trying to get to is generally Google or something. Google or Wikipedia or your general servers on the internet. And because you're trying to go to them, they can't accept this fully encrypted stuff. They've not negotiated keys, and if they had, they would have kept them themselves. So that's really insecure. This bit's always quite insecure. So where we come in is those services, parts of those services are all over these nodes. So these guys start being able to share data, share communications, and all the rest of it between themselves and between other mesh networks without the need for going to server-based solutions. And interestingly, with our system, these exit nodes don't need to exist. We can go back to the situation where anybody just picks the best route. Now what happens is this is encrypted on this side, and it's also encrypted here. So all this geezer here gets is an encrypted channel that's completely encrypted all the way through. So he can snoop if he wants, but all he's doing is providing bandwidth. He's not able to decrypt any of that. And because of what we're saying, the issue with the Skype thing, if this is a MaidSafe node, and it's ABC, for instance, and it's going to speak to DEF, it will go out onto the network to whatever node and get the DEF public key. And before he makes the connection to DEF through the bad guy's router, it's encrypted. So it's encrypted all the way to DEF through this router. Even better, the way that the system works is, if you're looking at this from the address perspective, the network addressing perspective, we'll put bad guy here. So this is this thing. The chances that so physically he'll be in that network, physically he'll be actually part of that network, and geographically and all the rest of it. But from an address perspective, or the kind of logical view, of the network, he might not be in the route. So the route for you from ABC to DEF could go something like this. And miss him out completely. Now, looking at it physically, again, he probably would appear physically in here. Because physically you go through, and this is quite hard to look physically and logically at the same time. Although physically he's there, logically he's not a node. So when this node is sending data, it will encrypt it to this particular node. That's the only node that can decrypt the data to figure out where it's going to go. So if you look at an RUDP packet on the wire, it's basically UDP packet completely with the data, or the payload part containing our RUDP. The destination for this packet isn't DEF. The destination for this packet is this guy here, XYZ. So he's sending data to DEF. He already knows he's going to go to XYZ. He encrypts the data to XYZ, flies it through bad guy can't read it. XYZ can read this. XYZ would know the final destination. If XYZ was also this guy, then he could know the final destination for this particular piece of data, this particular bit of traffic. And we look at our network, the traffic is so, if you're looking at data, it's going to take millions and millions of different routes, so there's a chance he might become a node in the logical network if his rank is good enough. He might get into the logical network. If his rank is good enough, he's in the logical network, it means he's providing resources. It's good for us that he's doing that. But the fact that physically these mesh guys can still go through a bad guy who's providing the resource is a really powerful thing. And that's part of what we never discussed on the Reddit thing. What we did discuss in the Reddit thing really was more the fact that we don't have servers and we don't believe in servers. And that's the real difference between the traditional ways of looking at securing information, because they're kind of say, I'll secure information to Shona, but Shona can be given it to the NSA if she's one of the NSA companies, which there's a lot of. So it's not a matter of you keeping data. Whatever you do with it, if you're a server and you're securing it or encrypting it, you're doing that so you can unsecure it and unencrypt it, and that's exactly how the internet works. So the Reddit conversation was more to do with moving away from a onion routing thing. That onion routing and coming out of Tor, exit nodes and stuff like that isn't really the answer as far as we're concerned. You have to encrypt the whole way. You can't encrypt part of the way and then say it wasn't me, it was a big boy that did it and ran away. You know, you've got to be fully encrypted end to end.
Are those guys aware of that? Is
They
it
were.
something we should be articulating to them?
Yeah, I think this is sort of, if the conversation had kept going, we probably would have added this kind of thing. And it's probably quite important that we get to know, but that's a good thing about recording these meetings now, because we should be able to go and speak to these guys and just say, look at this bit of video and tell us what you think and argue with us, or ask us some further information. Our drawings with more than one colour.
Yeah, we don't need the video, just put that up.
That's self-explanatory. You can just put that together into an infographic plan. But yeah, I think that there's a few things for the kind of mesh networking. When the whole MaidSafe thing started, it was one of the things that we spoke about is removing the requirement for ISPs, telephone companies, these kind of things. So this goes part of the way, and I think done properly, ISPs probably still need to be about for a long time, but we can reduce the requirement for them. So if your internet connection's busy, you might just fly through your next door neighbour's internet connection if it's not busy, so, and vice versa. And it is interesting because if you look at an internet connection, when it's being used to watch a video, it's being used quite heavily, but the amount of time it sits idle is ridiculous. So.
Anybody else got anything to say? Okay, well, lastly, David was contacted directly by a French company this week. They've got a substantial research and development budget, and David's going to tell us a bit more about what they're proposing.
Yeah, this was. Oh yeah, this is a guy that's been following us for quite a while actually, and he got in touch privately to discuss the possibility of a company being able to move large amounts of video about a large network, like a Europe-wide network, or maybe bigger. And they've got an interest in looking at, obviously, the MaidSafe network to do that. And it's built to move data about, so it's a perfect fit, you know, in terms of what they're doing. But video is quite interesting as well, because that probably goes into, I'll draw this up, opportunistic caching. I think this is where we really do things differently from other folk. So as well as the network that we've been talking about, caching is really important for video especially, because if you've got, the way that caching works, I'll put this up. If you've got the whole network all over the shop, you've got a group of people down here. So we know the way that the network works is if you're looking for a piece of data, there's a recursive thing happens. Say if you go at it, no, but I know someone who's closer. If you go at it, I know someone who's closer. If you go at it, I know someone who's closer. And then the piece of data is found. Why the caching is called opportunistic is the network takes this opportunity to store the piece of data as it's being transmitted back to the person who asked for it. And it will store it at all these locations. So that happens, if that's a video and you could be looking at several thousand chunks of data, and it's a person down here, you'll find that there'll be several thousand chunks down here. Some here. So the closer, if you look at it, the closer to the consumer of the data, then you have a greater concentration of the data appearing on the network. So if you're consuming that data, it'll wrap itself around you. If you then get another person who's also consuming the same data, so they're watching a video or something, they'll go for the same chunks and they won't have to go very far to get it. Then another one will appear here, then someone else, and again they won't go very far to get it, and maybe another chunk appears, someone else. Next thing, the data's actually all round the people that are currently consuming it. So the network does this through a thing called a FIFO memory. All this is first in, first out. So you can imagine that each of these nodes has got a container, and a piece of data will go in it at the bottom. Then the next piece of data, then the next piece of data, next piece of data, next piece, and so on. When that container's full, what happens is the bottom piece gets emptied and these all drop down. Again, another piece comes, the bottom piece gets emptied, these all drop down. So that's a first in, first out container. So that container's of a certain size. Each of these nodes have got this kind of container. And that's why, if you look at the network, you get this, as data is requested, more and more copies of it surround the person. And this node away here, which is far away from the consumer, there'll be, like any node, there'll be lots of data requests coming through it. So that piece of data will quickly drop out. So the network dynamically adapts itself to provide the data where it's required. So wherever it's stored, when it's being consumed. And from a video perspective, what the chap was looking for was a way of moving video transmitting it. And again, that's back to thinking about the old way of working. Normally, there'd be some great big server here with video on it, and we'd want it over here, or some of it over here, and he creates some great big channel and copy it there, because there's this thing about locality. People want data local to them for lots of reasons. They think it's better, they can control it and administer it and secure it behind some kind of firewall thing. So folk want local data for all that reason. But we already know that we don't do that. What we do is the data that's on the network is secure beyond encryption. So that's logically secure. So nobody can read it anyway, except the person who owns it. That logical security is only part of the thing. Most of the work involved is to do with, if you've got a piece of data, it's put on at least 4 nodes. And there's other nodes, there's another group of 4 watching this guy that are data managers. And this guy here will have another group of 4 nodes in another persona. If you calculate, there's something like 96,400 nodes confirming the actions of every other node in the network. There's 64 nodes probably directly connected to them, but each node has to behave itself properly. So that works out the administration. One of the really good things that the network does is when this guy goes offline and a copy of the data disappears, the network will make another copy of the data and remember that that guy had a copy and keep it as a ghost copy. If that guy comes back online within a certain period of time, which is dynamically calculated by the network, he might still be a valid holder of that data. If he's offline for too long, the network will actually penalise him for it and say, you're not even a ghost data anymore. You were off so long that we're penalising you. This is all dynamically calculated. It's all dynamically calculated and managed by the net. We don't put the numbers in here. We don't put a thing in to say if you're offline for 4 hours, the network would, you could be offline for 2 minutes and lose the data and be penalised if it's an extremely important piece of data. If it's not an important piece of data, the network might leave you alone for months. But so the good thing is that there provides your physical security in many ways. So you've got this, making sure that the pieces of data are actually in existence. And because of all of the, let's call them watchers, because of all the watchers on a node at any given time, The network is confirming that each node is behaving itself and doing everything it should be doing. So you've got physical security plus admin. Now, the admin's automatic. So this is quite an interesting thing. I wrote this recently somewhere. But when people want local data, one of the reasons they want local data is for this admin function, so that they can get administrators changing passwords and doing all the stuff that administrators do badly. The MaidSafe network does it completely automatically, and it will allocate resource through things like opportunistic caching or the ghost copies of data dynamically based on what the network requires at the time. So these watchers are the admin people, you know, and the famous thing about who watches the watchmen. In our case, it's just all maths that watches the watchmen. So in a normal situation when you've got servers, nobody watches the watchmen. The administrators can go as crazy as they want, they can make mistakes, they can lose stuff, they can be bought off, they can be bribed. In our case, maths is what we use to watch the watchmen. So if 1 and 1 stops becoming 2, we're going to have issues. But as long as 1 and 1's 2, and we're not daft at what we're doing, then it's really secure. So from the perspective of moving data or moving video, the actual answer is we won't move it from silo to silo, you know, for this particular person what they're looking for. But the network will dynamically allocate the resources and put the video where it's required at the point it is required. And it will make sure that the physical and logical security is maintained just through maths. So the answer is we don't do it. The network does everything for us. And that's it.
Any comments?
Questions, comments?
In that caching, it's not going to be people. You just say if it's access something, it goes on the top again.
Yeah, that's it. Yeah, that's right, man. When I showed the caching thing, I showed a kind of simplified version. So the next new piece of data that comes in would normally put this piece of data out, and we don't actually do that. If that's accessed, that piece of data is accessed, we actually put it back to the top. So the piece of data that comes out, it will only be out if no access during the time that this contains. So here, for instance, the data will be getting accessed all the time, so it will stay in that FIFO, it will stay in the memory. But here, it's probably not being accessed, that piece of data. It's probably not being accessed because it's much further away from the consumer, so it shouldn't get accessed. Another good thing about this, actually, if I remember, is if you had some bad guys about it again, and this was now a web server, or not even some bad guys, just, let's call it website, to use for the server thing. So if that was data from a website, and it was really, really, really popular, very popular, to some segment of society. So, say it was Scotland, and this was the census results or something. So we're all wanting to see who lived in our houses 100 years ago or something. At the moment when you put a website up to show this data and you locate it on a web server, because it's very, very popular, the server crashes. That's what happens. Come out the genealogical database in the UK, first thing that happens is the server crashes because it's popular. So in this network, when something's extremely popular, the network moves multiple copies out to the people who are consuming it. So not only does the network not crash, the server not crash, the response is much, much faster. So these people, rather than getting a crashed site for the genealogical study, are getting a very, very fast and crisp response to the data they're looking for. Or to put it another way, imagine that that's not a piece of web data anymore. Because we know we can have any kind of data in the MaidSafe network, including websites, that's simple. But imagine that's now GCHQ, or the government themselves. And at the moment, with servers, we have cyber warfare, as they're calling it, DDoS attacks, distributed denial of service attacks, taking these servers down. In this network, if you have a person down here trying to do a distributed denial of service attack, which is really nothing more than asking for the same piece of data over and over again, the network gives you that piece of data really, really, really fast, and it doesn't go back to here and crash the government. So we prevent DDoS type cyber warfare. It just can't happen. We just take it away. So rather than doing the snooping on everybody and coming up with massive firewalls and nuclear shelters and all the rest of it, again, just through maths, we get rid of denial of service attacks. Which is quite a big thing, because the whole cyber warfare thing's a bit of a joke when you come from the kind of MaidSafe way of thinking. No, it shouldn't exist. It's very illogical. It's really illogical that something that's popular crashes, you know. And I think that's one good thing about MaidSafe, is if we've done our job right, popular data should be faster than non-popular data. It shouldn't require much, much more servers and bandwidth and all the rest of it. The network should just repurpose itself and say this data belongs here, and that's it.
I think we don't have to worry about any cache coherency. Not at all.
No, well that's right, it's very, very clean, the cache.
Yes.
And
Because we just work with the hash of the data.
yeah, yeah, so there's no false hits or
Yes.
any of this kind of thing, because the address space is so big. So yeah, that's an important point actually. Anyone else?
Can I do this? Okay, that's us. Next week.
That's us for this week, is it? Excellent.